We present the Google Landmarks Dataset v2, a large-scale benchmark for instance-level recognition and retrieval. Our new dataset focuses on landmark recognition, a technology with many potential applications like visual search for recognizing famous buildings around you, personal photo search for organizing your image library, or gaming through augmented reality. In particular, this is an instance-level recognition problem, which means that the type of recognition task is very specific. For example, in a basic recognition problem, the image to the right could just be categorized as a building. In a fine-grained recognition setup, the label could be more specific, like church. But in our work, we're interested in instance-level labels, like Notre Dame Cathedral in Paris. But why do we need a new dataset for landmark recognition? Firstly, there are a few existing large-scale datasets, and of those, most feature a small number of landmark classes from limited geographical regions. Our dataset, on the other hand, is very large-scale, with 5 million images of 200,000 landmark classes from almost every country in the world. Secondly, many existing datasets have licenses that don't allow sharing images directly, causing the datasets to shrink over time and limiting their use in publications. The images in our dataset are directly available for download. Thirdly, existing datasets, like Oxford and Paris, are reaching saturation as benchmarks for recognition and retrieval tasks. We performed comprehensive benchmarking with state-of-the-art techniques and showed that there's ample room for improvement on this dataset. We also showed that our training set outperforms others at transfer learning. Here, global image features learned on different datasets are evaluated on the Oxford and Paris image retrieval benchmarks. Models trained on our dataset consistently outperform those trained on other popular landmark datasets. But our dataset also poses several unique challenges. Firstly, it's very large scale and has a challenging long-tailed class distribution. In addition to popular landmarks, it also covers many lesser-known local ones. Secondly, the test set was constructed to challenge the robustness of recognition approaches. Only 1% of the test images actually show landmarks, while the other 99% are distractor images from other domains. Approaches that recognize these distractor images as landmarks are penalized. Thirdly, our retrieval set presents significant challenges for image matching. Besides different perspectives, lighting conditions, and occlusions, it also poses cross-domain matching problems, like matching present-day photos to historic photographs, and even paintings. Finally, our training set has high intra-class variability. Images of the same class show different perspectives, including indoor and outdoor views. While some photos show the landmark in its entirety, others will focus on specific architectural details. Our dataset was constructed from two sources. The majority of photos come from Wikimedia Commons, while a small fraction was manually collected via crowdsourcing. We chose Wikimedia Commons as our main data source since it has millions of freely licensed landmark photos, organized in a well-defined class taxonomy. Thanks to the annual Wiki Loves Monuments contest, it has broad coverage of both popular and lesser-known landmarks around the world. To collect landmark photos from Wikimedia Commons, we first query the Google Knowledge Graph with terms like landmarks, tourist attractions, or points of interest. This gives us a list of Wikipedia articles, and from these, we can find the corresponding Wikimedia Commons categories which serve as our canonical labels. Finally, we download all photos belonging to each category. For the test set, there are two components: 1% landmark images obtained via crowdsourcing, and 99% non-landmark distractor images from Wikimedia Commons. For the landmark images, the ground truth is mapped to the Wikimedia Commons categories, which remain consistent between index and training images. In summary, we presented the Google Landmarks Dataset v2, a new, large-scale benchmark for instance-level recognition and image retrieval. This new dataset presents many industry-relevant challenges, like its long-tailed class distribution, intra-class variability, and distractor images that challenge the robustness of recognition techniques. We hope this new dataset will help advance the state-of-the-art and foster research that deals with these novel challenges. Our dataset is publicly available at this URL. Thank you very much.